last question. So the diagram shows a potential divider circuit used to measure the EMF of a cell. Both cells have a negligible internal resistance. Negligible internal resistance. Here's a 12-volt battery. Here's your another battery whose EMF is unknown, which is called as E, and the cell X. Okay. So you have a resistance in between. There's a jockey, which is a sliding contact, which will be able to move across. State what is meant by the EMF of a cell. What do you mean by EMF? How do you define? 2-mark question. So you should define this as work done by in moving a unit positive charge around the circuit is what you want to see. In fact, it can be much more precise. You can say work done per unit charge. You can say work done per unit charge. Work done per unit charge around the circuit, around a closed circuit. Around a closed circuit is what you call as the EMF of a cell. What is the EMF of a cell? Okay. Next, we have seen this, and then it goes. Right. Then AB is a wire of uniform cross section of length 1 meter. We write L1. The resistance of wire AB is 80 ohms R1. Then the length of AC is 0.35 meters. Length is L2. Then the current in the cell X is 0. Show that the resistance of the wire is 28 ohms. So there are two things which we need to know. First is formula, which is quite easier. The second one is to understand about how does a potentiometer or a potential divider work. Okay. Now let me go back here. He says the current through the cell, the current in the cell X is 0. Current in the cell X is 0. When will the current be 0? Only when it's an open circuit, first condition. Or the second condition is the potential difference is 0. See, I had already told you that whenever we have the potential difference is equal to 0, no heat current flows, no electric current flows, no water flows. Right? I'll once again reiterate it. Let us say, for example, I have a water bottle with me. Okay, and let me say I take 2 water bottles over here. I take 2 water bottles over here. So it is like this over here. And let us say there is a pipe which connects between these two. It's a tap which has been put over here. Let's say both the levels are the same. When I open this, okay, do you think the water will flow from this bottle to other one? Never. So what should I do? I should actually reduce this water level. I should empty this water bottle. Only then water will flow from here. So which means what? The height of the water is what you call as potential. If there is a potential difference, okay, if the potential difference, see, what do you mean by potential difference? The potential at this point and the potential of this bottle and potential of this water level, okay, if these two are equal, then the potential difference is 0, because potential difference here is V1 minus V2 will become 0 only. If there is a difference in potential, what do you mean by that? It means that this is at a larger height, this is a lower height. And definitely water will start flowing through it, right? So as a result of it, so there should be a potential difference, right? Okay. So in a similar way, you can also consider, let us say I have a spoon, and then I heat this one at this temperature. Will the heat flow? Yes, heat will flow, provided that this end and this end are at 2 different temperatures. And this temperature is a higher temperature, this is at a lower temperature. T1 greater than T2, only then the current will flow, what you call as heat current. In a similar way here also, if a current has to flow, then what should happen? The difference between this point and this point, he says through the cell is equal to 0, right? Between these two should be equal to 0. The potential difference should be 0. You can always say, even a battery, purchase a battery, it is 1.5 volt, means definitely one of them is 1.5, other one is 0 only. How can there be a difference? When I connect it in the circuit over here, and I adjust the resistance in such a way that I am not going to do anything here. I see to it that the potential at this point and the potential at this point, okay, I'll make it equal, okay, or maybe I'll make between these two I make it equal. So as a result of it, no current passes. Okay, that's what I am doing. So if no current passes through it, then automatically what will happen? Sorry, not between these two, between these two. Here it will not be. Okay, so So therefore, so as a result of it, so when I say V1 is equal to V2, no current will pass. Now let me come back to the question. Now the question says, if the length of the wire was 1 meter, the resistance was seen to be 80 ohms. If the length of the wire was 0.35 meters, 1 meter, 8 ohms, 80 ohms, 35 meters, then what is the resistance? Simple method, unitary method. What is the unitary method cells? The cells as R is proportional to L. Therefore, R2 by R1 is equal to L2 by L1. Right? So, what is R2? We do not know. So, I'll write R2 divided by what is R1? 80 is equal to what is L2? L2 is 0.35 divided by what is L1? 1 meter. So, thus we can write R2 is equal to 0.35 multiplied by 80, which would now be equal to, so the calculator nothing else, 0.35 multiplied by 80 would be 28 ohms. Check my answer. 28 ohms. Right. Okay, next. Determine the value of E. Now, how do you determine the value of V? So what you do is first find out, see, whenever you want a potential difference, straightforward thing is that either there should be a parallel circuit, or secondly, you should be having a current, and then you should have a resistance, and then take the product of these two, get the potential difference. Now you already have the resistance, right? R2 is already seen to be 28 ohms. If you know what is the current, you can easily find out what is it. Okay. So therefore, now what to do is you find out I. How do I find I? I is equal to V divided by R. What is V here? V. What's the value of V here? V value was seen to be value of E. 12 volt. 12 volt. When this was not connected, this was 12 volt, and what is this? 1 meter? No. Just give me a moment. This is 12 volt divided by resistance, 80 volts. 1 meter was the length, right? So V divided by R, 12 volt divided by 80 ohms. What is this? 80 ohms is 12 divided by 80 is 0.15. 0.15 unit amperes voltage. What do I need? I need the value of V, which should be I times R. R2. What is this now? 0.15 multiplied by R2. What is R2? 28 ohms. Sorry, once again calculator. 0.15 multiplied by 28 would be 4.2. So the voltage here should be 4.2. That is that. I think we have come to an end to all the problems for this week. See you once again next week. Thank you.